Alright, let's talk about today's Leetcoding challenge question, minimum pass sum. We have a n by n grid matrix filled with non-negative numbers. We want to find a pass from top left towards bottom right, which minimizes the sum of all the numbers along its path. And we can only move towards right or going down at any given point of time. It's a pretty standard dynamic programming question. So let's just be a little bit more generic here about this problem. Let's say that we have a function called Fij, which is the minimum pass sum from location 0, 0, the top left, to any given location ij. Then since that we can only going right and we can only going towards right or going down, the way that we reach this location is going to be from the row above it, or the column that's towards the left of it. So there are only two ways we can get to location ij. It's from i-1j or ij-1. So if we can just get the minimum pass sum for these two locations, then since all the numbers are non-negative, the minimum pass sum for this location is going to be choosing whichever is smaller from these two, and plus the integer at this particular location. So that's the recursive relationship we have in this dynamic programming question, and of course in the end we want to return f n-1 j-1 in the end. Yeah, so that's pretty much the formula for DP here, dynamic programming here. So we're gonna code up a 2D version and then minimize, try to optimize it a little bit. So before we do that, let's just run, for the sake of a demonstration, we run a quick example about how to solve this, how to actually populate the table for Fij. So we start with the top left location because it's a first location. It does not have any other ways, any pass before that. So the pass sum for that location 0, 0 is just the number itself. And then we look at location 0, 1. The only way we can come here is coming from the left. So we add 1 with the cell value 3 and just keep doing that. It's the same for the first column, that we can only going down, keep going down, and just adding the values. Then things become a little bit interesting when we're looking at the second row here, second row, second column here. We choose the smaller value between the cell towards the left and the cell above it, which is 2, and add the cell values 5 to it to get the Fij for that location. And we just do the similar thing. We get the 6 here. We pick 6, which is smaller, between 6 and 7, and add 2 towards it, so we get 8. And for the very last location, we pick 6 because it's smaller than 8, and add 1 to it and get 7. So that's so in the end we return 7. That's a little animation about how to populate this Fij table. And I guess one thing important is that you see that we're actually doing this row by row after we're populating this boundary here. So there can potentially be a reduction of space requirement by, when we are dealing with the row 3 here, all the information we need is the cell that's above, towards the left, or the cell value above it. We don't need anything about the very first row. So we can potentially reduce the space by only keeping track of the current 2 rows that we're working with. So we can reduce the space requirement from the whole matrix 2D grid towards 1D. So that's a kind of possible optimization which will be coded up very easily, actually, not difficult at all. So let's start code the 2D version first. First thing first, grab the n by n values here for the matrix. And we have a table, m row, n columns, and we're gonna start to populate the top left value to be 0, to be the grid value. And we're gonna have 4 simple for loops to populate the first row and first column. Row equal 1, row less than m. So this is the first column here, and we're gonna do plus grid row and 0. So that's the first row and first column. Then we do the first row here. 0 and column. Then we're starting working at the second row, second column, and just starting doing this row by row, column by column. So we're gonna have a nested for loops here. Yeah, the time complexity for this is obvious. It's n by n. So we since we're populating a table of size n by n, and for each cell we do a constant time operation, so it's the time complexity is n by n. For this 2D DP version, the code is gonna take n by n in space. So yeah, I can actually copy this. Cool. So that's the then we just use this formula here. dp row and column is equal to the grid value at that location plus the minimum of whichever direction that we can coming from. So that's I minus 1 c row minus 1 and column, or row and column minus 1. So that's pretty much the 2D version. And in the end, we just return n minus 1, n minus 1. So it's pretty much literally this couple of lines here is literally just duplicate this formula into actual code. Let me quickly check. Initialize empty table. The top left is the value itself, and then we do a first column, first row. Then we start working on the second. The interesting part, which we need to do a decision which parts we take. So it looks okay. So let's submit this. Okay, so we're gonna try to reduce this a little bit. Okay. So this is a 2D version, mm in time, and order mn in space. So for the one-dimensional one, we're just gonna store the single line here. And so let's actually do a quick demo. So remember the matrix is up here. So we populate the first row, 1, 4, 5, and then when we decide the next row, we're gonna take the current value and add 1, So that's the only location, only thing we can do. So we update this one to be 2. I'm gonna write it as separately. So just so you know that we basically just modify this in place for the for this one, for the zeros location in the 1D DP table. The very first location, it's always going to be the cell value plus the one that's up, plus the previous cell value itself, because that's the only way you can get there. And then when we look at the second location, it's the minimum between 2 and 4, and plus the 5 there. So it's 7. And for the third location, it's the minimum between the cell above it, which means that we're coming from left in the same row, or the value itself, which is the previous value. That means that we are coming from the row above coming down. So we take the minimum between 7 and 5, which is 5, and add 1 to it, so we get 6. I'll just keep doing this for one more time. When we look at the very first location, we can only going down, so we add 4 to. Let's just make a copy first, and it's gonna be changed to 6. And when we look at the second location, we check take the minimum between this value and the one that's up prior to it, and add the number 2, so we get 8 here. For the last location, we can compare 8 and 6 and add 1, so we get 7. So that's for this 1D version, we're just gonna keep 1 dimension. So we're gonna have with n numbers in there. The very first value is gonna be the top left cell value, and we'll populate the very first row very quickly, which is just to copy this. Oh no. Less than n C++ dpc equal to dpc minus 1 plus grid 0 and c. That's we populate this first row, then we just modify the values inside in place. Plus plus. What we're gonna do is for each of the cell values, if it's 0, we add the number to itself. Otherwise, we will do a minimum between the adjacent number and add the cell value to the minimum of the 2. And C++. If we are at the first location, then we're gonna do is directly increment that. Jeez. Typing. Otherwise, it's gonna be similar to the formula, to this formula here. Which is going to happen between the DPC and DPC minus 1. The DPC here means that we're coming from the row that's directly above it. DPC minus 1, it's we're coming from the same row, but the cell, the column that's towards the left of it. So that's the code for the one-dimensional one. So this will reduce the space to just based on the number of rows. So this one is 1 dimension, and this is the space. So looks okay to me. Let's see. It's not working. Okay. Jeez. let's do some check. I don't want to see this error message anymore. We have this. Yeah, this is the number of columns, the size of the number of columns. So yeah, I need to change the space here. We populate the first row, and then from the second row towards the end, we looking at the cell by cell. If it's the first cell, we can only coming from above, so we increment the cell value by the grid value. Otherwise, we can have choices, either coming from above or we coming from left, which is the minimum between these two, and we add the cell value. So yeah, this looks right now. Okay, it's accepted as well. Okay, that's the question for today, a minimum pass sum.